what we have here is the assortment of multimeters that are in my shop and have been in my shop for years, with the exception of this new one that is the reason for today's video. So in my preliminary testing, and I have not taken this one out of the package. I did open it to make sure I knew what it was in the package, but I've not taken it out of the package yet, so we'll be unboxing it together today. I tested all these against each other. Well, not these two. I tested this cheap Harbor Freight, the Craftsman I've used for years, the Syntec Harbor Freight one, and I tested them for voltage on couple different batteries, and I just used drill batteries or car batteries. I got some different resistors out and tested them against each other on resistors, and these, you know, were quality resistors that I've been using for projects, and they were all within a thousandth of a volt, or maybe I should say a thousandth of a ohm of resistance, and a hundredth of a volt, because that's about as deep as it tests. I don't know which one is 100% accurate. I don't have the equipment to test them to that degree. A shootout really didn't work. I mean, they all work very similar to each other, and I don't have the testing equipment to take them out to the millionth of a volt to see if they can read that. What we're here for today is this new one, and I'm going to tell you right now. So, you know, in fairness, up front, this is a sponsored video in that this meter was shipped to me by the manufacturer, who sells here in the United States via Amazon, and asked if we would be interested in reviewing their product and maybe doing a comparison or using it around the shop. And I thought I was going to do this big shootout. Really didn't work out how I kind of envisioned, because there's no solid way for me to test it compared to these others, other than I will run the same test, the voltage test, the resistance test, and the continuity test, and make sure we're getting similar number. But again, if it's within a hundredth of an ohm or a thousandth of an ohm and a hundredth of a volt, that's about as much as we can test with anything we have here. So this is a digital multimeter. It's shipped to us from a company, and I'm sure I'm mispronouncing it, but it's Kaiweets Direct, and that's out of North Las Vegas, Nevada. And I'll put a link to this in the description so that you have a chance. They have some really cool products on their Amazon site. They have a couple different versions of digital multimeters. They had some laser stuff, a lot of neat tools that if this works out really well, and maybe I can bring some of those others to you as well. So let's get this opened up, and we'll use the smallest tool I could find in the shop to cut the little seal. So here we go. Comes with instructions. Multimeter wrapped in plastic. We get, a couple of nice things. We get batteries with it. We get a set of probes. Pretty good length. A nice probe end on here. It's got different removable tips, so you have a very fine point tip. And actually that looks like it's about all. So I think that though will let us put a different probe end on. We'll test that here in a minute. It comes with a type of temperature probe, maybe? Yeah, I would say that's a temperature probe with some good length on it. Okay, it comes with two really nice long leads. They do say they are 20 gauge. The probes have a removable end, so you have a really small probing point on there, and then you could remove that, have the full length, which I think will allow, let's try a couple of our other parts. I think that might, well no, it won't work with that, might, or with that. So I'll have to check and see if there are some different attachments that we can make to this. The nice thing is this end does appear to be the banana clip style, so it plugs in, and so with that the probes that I like here that have this banana clip style end that allow you to put different plugs on there, these should plug right in as well, and they do. Again, we have the banana clip style probe here that you can plug in for your temperature sensor. Alright, something that bothers me a little bit is the one that you plug the ground into appears to be loose. Maybe that's a feature just to keep them from... When you plug this other style in, that barrel of it is going to protect from that. But that is something to look into. I'll talk to the manufacturer. And it has a screen protector. It does have a rubber case on it. There's a little area back here where you can put a screw in the wall and hang it up. It has the foot. So I like that. So it has places here for the probes to be stored, it looks like. That's a nice feature. In this, we're looking at the Kaiweets HT118 Alpha 118A model. They had, like I said, they have several different models on their site. A couple of interesting things. This has an NCV tester, which is a non-contact voltage tester, and that's here in the top of the meter, and it tests for AC signals. So we'll be looking into that. It also has a flashlight here on the back. So once we have batteries in there, we can test that, see how bright that is, and you know, maybe that would be useful if you could set this up, kind of point it at what you're working on, and test on this side, and you're able to read the meter over here. Okay, we've now got this ready to power up, and the first thing we're going to want to do is test voltage on this battery. It tells you how to do all of the different testing here in the instructions, so that's kind of nice. For AC and DC voltage measurement, it tells us to turn the knob to the first source here. It's kind of nice. It also lights up some green LEDs. They blink a few times to tell you which ones are the probes. So we're testing this on an 18 volt battery, which should have a little more than that. It just came freshly off the charger. And it does. We have 21.25 volts. I just picked which probe to put on which. But if I do them backwards, now you can see the negative sign right here. That tells us that the voltage that we're testing right now is reverse polarity compared to how we have the leads. So one of the warnings they do tell you to test with, or when you're testing, is not to test for over 1,000 volts DC or more than 750 volts AC, which means this is going to be a very good, useful product, whether you're doing DC on heavy equipment and in the 24-48 volt range, or whether you were testing residential or even commercial circuits, you know, up to 750 volts AC. Well, in my place, the most I run is 240, so I'm well within their range. But that becomes a nice feature. So leaving the probes in the same location, the next setting here is for measuring. This is going to measure either the frequency or the duty cycle of a circuit. So on this next feature, we're using the hertz and duty cycle. And what we're going to do is test a 112 volt outlet, 120 volt outlet rather. What you can see now is we're showing roughly 60 hertz, 59.98, which is typical for your household in the US. We run at 60 hertz. So in the second function, we have the ability to test for continuity. So when these are not connected, we're out of limits, meaning it's infinite resistance. We touch them together. We're going to, and it should come very close to zero. So 0.001, so 1/1000th of an ohm of resistance. Hit the function key here, we turn on the sound feature. There we go. So now with them touching, we only go out to 1/10 of an ohm, but we also get a green light and a nice oral warning or oral sound that we've got continuity. So that's great when you're testing in a car or testing circuits where you just need to make sure things are actually functioning correctly. So we can go back to our, so that would be for diode. There we go. We can go back to ohms of resistance. This is a resistor that we're testing now, and it's showing 2200 ohms of resistance, and that's exactly what these are. You can see here 2200 ohms, so 2K2, that's 2200 ohms of resistance. You can check this other one, which is a 15,000 ohm resistance. Oops, if I get it on the actual resistor, 15.02, so 15,020 ohms of resistance in that one. So we could assume that that is, and if we test multiple resistors, we'll get some slight variance in there. So those are both testing correctly. Hit the function key again, and we get the little symbol up here for a diode. And the diode is, that's what one, there's what one looks like. There we go. It looks very much like a resistor. A diode is essentially a one-way gate. If you have electricity that you want electricity to go one direction but not be able to reverse, the diode is the gatekeeper, the what prevents electricity from going multiple directions. So we test that. There we go. So when we test it one side, electricity goes through, we get, but when we go the other way, reverse our leads, we get nothing. The electricity is not going. So essentially the power is trying to go, sending a small amount of voltage, looked like about 0.6 volts, from the positive lead towards the negative lead through the diode. So it's 0.637 volts is what's being sent through. And when we switch the leads to try and go the other way, nothing goes through. So we know the diode is good, telling us that our tester works. So this is a capacitance test. It would be testing the ability to test a capacitor. I don't happen to have any here in the shop. Rarely have I needed one, but you would be able to test your capacitors there, and the instructions actually walk you through that. So it's a neat feature. The next thing is a temperature test. Before that, we need to start our temperature coupling. And it says you put the black in the common position, and which is the black one, and then the red one goes in the same tester, same port we've been using. And it says it's cooling off really quickly. Actually, it's stabilized. 34 degrees Fahrenheit in here. And I can tell you, it's cold. I didn't think it was that warm, but I know it's cold, which is basically 1 degree Celsius. So depending on where we set it, we hold it in our hand here for a few minutes, you can see it actually reacts very quickly. I'm pretty impressed there. But it gives us temperature in Fahrenheit and Celsius. Okay, so these next three are for testing AC and DC current. And with these three, you want to use the 10 amp function so that we are in a fused circuit, so that if we're testing anything that is up to 10 amps, we can test the different levels of amperage being tracked through a circuit. If you were wanting to go all the way down to milliamps, then you can do it on this one. These are the times you would use this secondary feature. This would be great if testing, and maybe you've got a battery that's going bad, you've got a dead. So we're going to build us a very basic circuit here, but think of this as in your car, maybe motorcycle, and you've got something draining your battery. So you have your two battery cables, your negative going to your ground, and your positive going to your positive battery terminal, and something in the car is draining power, much like this light bulb is now. Well, if you take one or the other of these off and put your probes in between them, the light's still on, we still have the drain, but now we're able to start measuring the voltage, and it's telling us it's out of limits for where we have this plugged in, because I have it plugged into the millivolt, and it was beeping at me and telling me we're out of limits. So we'll try it again here. So it's telling us it's measuring DC, and we're drawing 1.2 milliamps of voltage with that light bulb. Well, over time, that's going to drain this battery or any battery. So if you have, that's how you would test this. You use this in the circuit. That's what these three features are for. The function button here allows you to switch between AC and DC so that you can test household circuits or commercial circuits up to 750 volts. Okay, the final feature we're going to discuss is the NCV, and that looks like an NCU, but go there and it's picking up this extension cord. I have it plugged in over at the wall. If we come over to it, see it says there's a high, and it kind of cycles back and forth between low and high depending on where I'm at in on the cord. Maybe a little here where there's there. So you got the black wire, which should show high, and then if you get over on this side where you're a little closer to the common, we get the low, and just take it away, it goes away, and you can hear it beeping. And that's all based on the voltage here. And one more thing you can do is use this. You can plug your red probe back into the probe common point we've been using most often, function, and go to live. And now this probe will test for live AC power. And for those of you who aren't aware, 3-pin connector in your house, this is your ground. The one that's larger than the other, it's a little taller, you know, they're both the same width. That is the common, the white wire in your electrical system. And then the short one is the black wire, the live wire. So if we put the probe into the ground, we get nothing. We put it into the common, again, we get nothing. In most households, the common and the ground are tied together somewhere in the system. And then in the black, or the short one, we get the live signal. And that's just telling us, hey, we have live voltage here. If you were about to start working on this circuit, you would want to go turn the breaker off until that went away. So that's a great little feature. Overall, what I found in playing with this for a little over an hour now, I realize this video is not nearly that long, but I've kind of played around testing the different features and making sure I understood how they worked. What I found is it's been a really good meter. I would mostly find myself using the voltage, continuity. I think out here in the shop, I've been doing quite a bit of wiring, getting things ready out here, adding power and circuits in different places. So I might find that NCV feature useful. It would be the live feature especially would be a great feature to use to make sure you've got the power turned off before you actually start working on something. I like that the green lights light up, and you know, you get a visual and a audible signal when you're doing continuity. Oops. So when we're doing continuity, it's lighting up green over here, telling us which ports to use, and then we can select over to continuity instead of resistance. There we go. We get the oral and the green light. I like those features. It does have a backlight feature, which I think is very useful, especially in dimmer settings. You're working underneath the car. And then if you hold this down for, it says 2 seconds or more, you get a little LED flashlight. I was more hopeful that it would be brighter than it is. I guess if you were laying up underneath the car already, looking underneath the dash, trying to find a fuse or something that you were wanting to test, maybe that light would be useful. I don't know. Probably didn't cost them very much to install that extra feature, but don't know how useful I would find that. The rest of it though, max and min, that button allows you, when you're testing a circuit, to look and see where something's moving in and out of a range, and then you can use the hold to hold a screen, so that maybe you're testing around like this, and if you can't actually for some reason see the meter, you could hit the hold button and come back and look and see if you got it. I again have rarely used either of those features on other meters, so I don't imagine I would use them very often on this one. It's plastic. There's not a lot of durability here that I would be afraid that we might damage the leg. But it does have one, which makes for a nice feature. And Well, so this was a little different video for us in that this is the first one I've ever done that was sponsored and somebody sent us a product, and I want to give a fair review of their product, but also give you a fair evaluation of what it is. I think the quality of leads and the body of the product are well within the hobbyist user function, level, and I would certainly consider this a usable tool here in my shop. And in fact, we will be using it on the next couple of wiring projects, maybe not exclusively, but we'll try and make it our primary, just so we can see how its durability is, and then we can do follow-up videos if we need to on that. Overall, the functions are well within anything I will ever need, and it also looks like the level of measurement is well within my usage. And I do some basic electronics and stuff. I do build some circuits occasionally, and found that it would measure well into the ranges that I needed to know. I want to thank Kaiweets for sending it out, for sharing it with all of us. And then, like I said, you'll see it around the shop, and we'll make some good use of it. Again, thanks for watching. Please like and subscribe. Leave a thumbs up for more Tool Bag Tuesday stuff. There are multiple videos in this series, and go back and watch those if you missed something. So for those of you who didn't quite catch what I was doing with continuity and resistance and diode testing, I have a whole series of videos on how to use multimeters in the help series of videos that I've done in the past. And so go back and catch those. I'll try and put a card up for a playlist for those. Please give us a thumbs up and a like and a subscribe for Tool Bag Tuesdays. If you want to see more of those and see other vendors that are out there. This one's great because Kaiweets shared this with us at no cost to us. So like I said, it is a sponsored video, but I will leave a link to this and to their full store on Amazon in the description. So again, thanks for watching. We'll see you again next week with another Allison Customs Project Car TV video.